Hi all, welcome to part 7 of video lecture on ER model. So far we saw what is entity, what is relationship. That is the main thing we discussed, and now we are almost about to draw the diagram. Okay, now as a final step we have to know something called the constraints on the binary relationship type, and you have to mention these constraints also clearly in the ER diagram. That only completes your diagram. So this is something important. Okay, so basically we talk about two types of constraint. One is called cardinality ratio constraint and another one is called participation constraint. Okay, so it's both are important, and you can expect separate questions or compare between these two like that. Okay, so constraints are like, for example, if the company has a rules that each employee must work for exactly one department. Okay, so means I can't allow a person who is not mapped to a particular department. So if I can call a particular person as employee, it's provided he should work on at least one department. So that is mandatory there. This is one example. Okay, similarly you can think about any constraint. So how we are going to capture this constraint in the ER diagram is what matters. So one by one with some small examples we will see that. So the relationship types are usually have a certain constraints or like this, that limit the possible combination of the entity that may participate in the corresponding relationship. So minimum how many can participate, maximum how many can participate, but basically it is from the mini world situation, right? So from one mini world to another mini world the constraint will vary. So it is very important that during requirement gathering phase these constraints you should clearly communicate with the user, and what are all the constraints the user is in need, that you have to try to represent using that ER diagram. Then you have to communicate the ER diagram with the user, so that if any change is needed, he can do that. Okay, so that about it. So first let's start with something called the cardinality ratio constraint. So as the name says, it's saying about some cardinality, some counter, right? So it's particularly the maximum number of relationship instances that an entity can participate is its cardinality ratio. So given on entity, maximum how many relationship instances this entity can participate, that will be its cardinality ratio. Let's take an example. For example, this works for relation, hope you remember, employee is working for a department. So if you are looking at the entities department and employee, you can see that they are having the cardinality relation, cardinality ratio 1 is to n, meaning that if you are looking at a department, each department instance is participating in a single relation instance. But if you are looking at the employee instance, some n employee instances are participating on a particular relation instance to a single department. Something like a single department can have a n number of employees. So basically that is the meaning. Okay, don't confuse with the definition we will see later. The maximum number of relationship instances that an entity can participate in. Okay, so here you can see that. Okay, so why this example? So meaning that each department can be related to any number of employees. So look at any one particular department, you can see that this department is being mapped to some n number of employees. That is the meaning. And what is this n? So typically this n says that there is no maximum. There is no maximum. So in general I am saying some random value of n. So this is not a fixed number. I am not saying like 100 employee or 1000 employee. I am just saying that there is no maximum. Some number of employees will be participating in a department entity through a particular relationship instance. Okay, so something like that. But if you are looking at an employee is not supposed to work on more than one department. So employee can be related to at most one department. So the cardinality ratio of the employee entity with respect to the works for relationship is 1, saying that an employee instance can participate on at most one relationship instance, works for relationship instance with the department entity. Similarly, if you are looking at the department entity, the cardinality ratio of the department entity is n, meaning that a particular department can be related to any number of employees through different relationship instances. So the same department can have n number of relationship instances with n number of entity instances. Okay, where a particular employee entity can have at most one. At most one. Okay, at most one. Okay, so that means an employee can exist without working on a department also. All those things are up to the mini world. Okay, so what is the specification given from the mini world? Suppose in the question paper you are confused, like whether an employee. So at this point I'm slightly confused, like whether this employee can exist with or without a department. If you are confused at any point, so this you can take your own assumption. I mean, in the exam point of view, I'm telling you, you can assume that an employee must work. If I am calling a person as an employee, he should work in a department. That you can assume, no issue. But you have to clearly mention in the answer sheet, like this is my assumption. Accordingly, I drawn the diagram. So that is fine. So don't think too much. Like if we can expect that that specification will be clearly given in the question paper. Otherwise, you take your own assumption and write it clearly and then draw the diagram. That's all. Okay, so that about it. So here you saw something like a 1 is to n relationship cardinality ratio between the department entity and employee entity under the relationship works for. One department can have n employees. So that is the final conclusion. Okay, so that is a meaning. Similarly, you can think about this n is to 1 also if the direction is reverse or some other cases, and you can think about 1 is to 1 as well as m is to n relationship, like a cardinality ratio. So cardinality ratio constraint talk about the maximum number of relationship instances that a entity instance can participate. So this is the definition. So this is a maximum number of relationship instances that an entity instance can participate. So that is our cardinality ratio, and it is of 4 types: 1 is to 1, 1 is to n, n is to 1, and m is to n. 1 is to n and n is to 1 are same only, but in different direction. 1 is to 1 we will see an example. So this is, you can take as an example for 1 is to 1 cardinality ratio relationship. Managers, right? So an employee is managing a department, and you can see that if you take any department, there is supposed to have a exactly one employee as a manager, right? And also one employee is not supposed to be manager of more than one department. So that is the meaning. So both side, the employee instance is participating to at one, I mean maximum, minimum. At this point we are not thinking about minimum. That is the thing. Minimum cardinality we will be representing using a different constraint called the participation constraint. We are going to see it next. So right now we are talking about the maximum cardinality only. So if you are looking at maximum, an employee entity can participate into one managers, I mean one employee can be a manager of at most maximum one department. Similarly, one department can have a maximum of one employee as the manager. So that is meaningful, right? So 1 is to 1 relationship you can see here. And another example is like m is to n. So this is about 1 to 1 correspondence. And here we have the maximum cardinality as m is to n, in the sense the works on relation, it is not works for. Works for is between employee and a department. Okay, employee is working for a department. This is a employee is working on a project. Okay, now you can see that if you are looking at a particular project, there will be a number of employees working on the project. Okay, so the cardinality of this cardinality ratio, or ratio means together, you have to say cardinality of this project entity instance is n. So here it is 2, but in general case I can think of any number of employees on a particular project. So here I can say that the cardinality is something like n. So here this E1 is participating and E2 is also part of this particular project. Okay, fine. And you can think of more also. So there is nothing like, if it is exactly at most 2, then you can say like 2 also. But here this n in general we mean there is no upper limit. So it can be any number like that. And at the same time, if you are looking at a particular employee, you can see that one employee can work on this E3. If you are looking, he is working on project P2, he is working on project P3, and he is also working on project P4. He may be efficient like that. So it is participating on the relationship instance R4, right? It is participating on relationship instance R5. It is participating on relationship instance R6. Accordingly, other side we have entity instances like project instances P2, P3 and P4. So like that you can think of anything. So in general here also I have to say like n. So I am using a different number, that is m. That also says another variable. So maximum is not limited, like it can be anything. Okay, so a particular employee can participate on some n number of projects. Also, if you're looking at a particular project, it will be participating, it will be having n number of employees working for it. Okay, so that about it. So this is an example for m is to n. 1 is to n we already seen, like that our employee works for a department. Okay, so now this concept is clear, and all these things, again I'm repeating, it is from the mini word specification, that should be clear. If you have any confusion, you can take your own assumption, and accordingly you can draw the diagram, but the assumption should be mentioned clearly in the answer sheet. And if you are looking at the notation is something like this here. If you are seeing this employee and sorry, this works on, and the other side we have this project, we denote like this number, this maximum cardinality m or n or 1, that will denote over that straight line. There are different notations also. What I am talking is about that Navate textbook, so they are explaining your diagram like that. Maybe slightly different notation also somewhere I saw, but this is the popular one. Okay, so standardized one. Cardinality ratio for the binary relation are represented in your diagram by displaying 1 m or n, whatever it is, on the diamonds appropriately, I mean near to the diamond on both sides. Notice that in this notation we can either specify no maximum, this n says that there is no maximum value, and 1 says that there is at most 1, like that. But if you want to specify exactly some maximum number like 4 or 5, that also possible. Okay, so typically we will use this n and 1 kind of notation, but sometimes if we are more specific about the maximum count, you can use that number also, that also fine. Now, just like the maximum cardinality ratio constraint, we have a minimum cardinality ratio constraint called the participation constraint, or the existence dependency constraint. Whether the existence of something else is needed for existence of something else, like that. Whether one entity is depending on another entity for its existence or not, like that. So that is one type of participation constraint. Sometimes it may be depending, sometimes it may not be depending. So accordingly, there are two types of participation constraint, that is total and partial. Okay, anyways, we will see with an example, that will be fine. Yeah, one thing you can think about is participation of employee in the works for relation is called total, in the sense, you take any employee, we already seen that the employee is supposed to work on a department at least one department this employee should work. So this is something I told you. So now it is clear. So at this point they are writing like the participation, if the company policy states that. So this is important, if the company policy states that, otherwise you don't have to worry about. This is a constraint that is coming out from the real world. The company policy is saying that every employee must work for a department. So if this is the case, every employee must work for a department, then the employee entity can exist only if it participate in at least one works for relationship instance with the department. So employee entity can't exist without participating any department, a relationship instance. So every entity must works on at least one department. So that is the meaning, if the company policy says so. In that case, I can say that the employee entity is having a total participation with the works for relationship, meaning that every entity in the total set of the employee entities, you take any employee, so you take set of all employees, take anyone, everyone should participate on the relationship. That is must for us, that is why total. So if I am looking it as a function, every element of this employee entity set is mapped to a relationship. So that is why you, in the normal meaning, function itself, we have a total function and partial function. So same thing here, the function is total in the sense everybody from that left side of the function, that employee entity is participating with someone on the other side through that relationship instance. Okay, so that is a total participation. Total participation is otherwise called existence dependency. So the existence of the employee entity is purely dependent on department. Without having a relation with any department, the employee entity is not supposed to exist. Okay. Yeah, that about it. So it's also called existence dependency. Now another one is partial participation constraint. As the name says, it's just like the partial function where all elements of the domain may not participate in the particular relationship instance. For example, if you are looking at the managers, every employee is not going to be a manager of some department. There may be some employees who are not managing any department, that is fine. So managers, if you are looking, one side we have a employee as the entity, and the relationship I am having is just like works for. Here I am having the managers relationship, and the other side I am having the department. Okay, and now I can say that if I am looking at any employee, so this is one thing we discussed, and another one is like a employee is working for the department, same employee only, or you can same diagram you can so here I am writing independently. Okay, but you can combine like this also, that is also fine. Okay, so here if you are looking at this one, the participation is total. Typically we denote total participation by double line. Everybody should participate. But if you are looking at this one, the participation is partial. So single line means partial, in the sense every employee is not supposed to participate in the manager's relationship with some department entity, but every employee must participate at least one relationship instance with the, works for relationship instance with the department table. So that is the meaning. So here this is partial, meaning that some or part of the set of employees entities are related to some department entity and not all. Okay, so that about it. Now this cardinality ratio is giving you the maximum cardinality constraint, where this participation constraint is giving you the minimum cardinality constraint, and together this partial and cardinality ratio constraint together we can represent using something called a structural constraint, where this maximum and minimum value we represent by parenthesis, and this double line and all we eliminate in case of structural constraint. Anyway, we will see the structural constraint and this notation in some later session. That complete diagram when we are drawing, that time I will introduce you how to draw this cardinality ratio and participation constraint independently, and also how to draw combine both of them using structural constraint. That we will see later, okay, when we take a final example. Okay, now hope it is clear. So what we discussed is two types of constraints, mainly the cardinality ratio constraint and the participation constraint. Cardinality ratio constraints are talking about the maximum number of relationship instances that an employee that an entity instance can participate, where participation constraint says about the minimum lower bound, this is a upper bound. Okay, cardinality ratio 1:1, 1:1, n:1, m:1. Those things are clear for you, and the notation also you know. Participation constraint total and partial, whether everybody is participating or some subset of it is participating, like that. So double line corresponds to total participation and single line corresponds to partial participation, and together cardinality ratio and participation constraint we can represent using structural constraint. Okay, notation is given. The total participation is represented using double line, where partial participation is represented using single line. So keep that in mind. We can specify partial in the sense there is no minimum. Okay, and a minimum one means total, at least one. Okay, now if you want you can say the minimum is some 4 or 5, just like the maximum is some 4 or 5. So that possibility is also there, but typically this partial and total constraint is what we are using, but if needed we have that alternative way also. Now relationship type, this is something I already told you. Just like entity type, relationship type can also have attributes. For example, if you are looking at the works on relationship, the employee is working on a project, how many hours he is working per week, that you can represent by just like the employee is working on a project. Now I can say, I can give an attribute this works on relation called hours, where I can denote how many hours this particular employee is working on this particular project in a week, like that. Similarly, the managers relation, employee managers department, you can denote the start date, from which date onwards he started managing the department, as an attribute to the managers relationship type. So like that we can think of attributes for the relationship also, and how these things are actually implemented, and those things we will see later. Okay, now you got an idea. So that about it. So the topic I discussed in this video is very important from exam point of view. So this topic typically frequently used question, like a cardinality ratio and participation constraint differentiate, like that. Okay, Yeah, any doubt you can clarify. And also we will see very soon that complete diagram representation, and that time, even though you have some doubts on this cardinality ratio participation, it will be cleared. Okay, I will repeat again for a general scenario. Yeah, thanks for watching.